All right, so everybody, hi, welcome, and good morning. My name is Danica Fine. I am a developer advocate at Confluent, and it's been a pretty long journey for me to get to Melbourne. I'm from California. I traveled to Singapore with my colleague. He's also giving a talk here later this week. And so we were running around being developer advocates for a bit, went to Sydney, and now we're in Melbourne, and we're very excited to be here to pretty much round up our trip at NDC Melbourne. Today I'm going to be talking to you about Kafka, Confluent, in the context of building a streaming data pipeline. But it's not just any stream data pipeline. We're going to have fun with this, okay? Mostly because I am a plant person. I have a problem. So every time I travel, I love traveling to this area because I get to go see new plants that I don't actually see where I live. And most of the plants that I see, even out on the streets, are things that I can only be houseplants where I live. So that's pretty awesome. So how many of you have houseplants? I want this to be a motivating thing. Okay. Okay, cool. How many of you have that weird goal of, I hope it's a common goal, of having a jungle in your house? All right, non-zero. That's good. That's good. We can probably be friends. So I have a plant problem, absolutely. This is a small subsection of a subset of the plants that I actually have. I have about 4 dozen throughout my house. I love plants. They look so nice, okay? It's decoration, but they're alive. It's so cool. I have been collecting plants for a number of years now, just because, yeah, they're aesthetically pleasing. I think this is great. And also when people come over and you haven't killed a plant, like it's nice to brag about it, right? Like, hey, this thing's been alive for 5 years. What about your fern, huh? It's dead. So anyway, I love taking care of my plants. I've collected a bunch of them. It's really gotten out of hand the last couple of years because I've been at home, okay? And I'm like, that's an empty space on the floor. We can put another plant there. So I've definitely increased my collection over the last 2 years. And that's well and good. But then you realize that it takes effort to take care of plants. I don't know if any of you plant parents have experienced this, but it's, you can forget about them a little bit, but then you gotta check and see when they need to be watered. Sometimes a couple times a day, depending on where they are. Do they need to be rotated, get more light, more fertilizer? Do I need to trim anything off? There's a lot of hands-on work that goes into keeping a plant alive. And I love that. My boss did not like that because I am spending more time every day doing rounds on my plants than, doing work that I probably should be doing. So I needed to solve this problem. And also beyond that, I was just being a really bad plant parent. So I'm a remote worker, but occasionally I go into the office. And on this particular day, I just didn't do the rounds. I didn't check my plants, didn't see if they needed to be watered at all. And I came home to this very, very dramatic sight. This plant's okay now. They just kind of do that, they faint. But I felt really bad, okay? If I just checked the plants or if I'd known the night before, this wouldn't have happened and I wouldn't have been so depressed. So, is there a better way for me to be doing this, right? I wanted to monitor my plants and I think there had to have been a better way than just running around and checking on them all the time, right? And I know what you're thinking. There are obviously pre-built solutions that you can get to monitor your plants. I can just run to the store, probably pick one up, get it off of Amazon, whatever. So that's the wrong question. We're engineers, right? So the question is there a more interesting way for me to solve this problem? Can I monitor my houseplants in a way that's kind of fun, right? Do I have the technology? Or is there a technology that I want to be using? Do I have the willpower, probably, to build a solution that's going to solve this problem, but in a really fun and interesting way? So my thing is that I'd always wanted to build out a hardware project using a Raspberry Pi, and this was my chance, okay? This was my chance to build something in my home that I actually needed, right? I feel like it's, when you're starting off on hardware projects, the first thing you want to build is something that's actually useful to you, because then it's motivating, you want to build it right. There's a lot of pros to that. So this was my chance not only to use a Raspberry Pi, but to also use my skill set around Kafka and build a Kafka pipeline in my house that was going to actually be useful, and hopefully useful to you guys as well. So with that in mind, let's talk design. I know this is a really, really sad high-level diagram, back of the napkin scratch pad, but this is kind of what I wanted, what I envisioned, okay? I needed a system that can monitor my houseplants and tell me when to water them. If I could do that, then I can avoid a lot of the sad plants around my house, right? Pretty simple system. I'd have a soil moisture sensors connected to Raspberry Pi and just take some readings. Throw that in Kafka, probably. I also knew at that moment that having the readings alone isn't going to be enough, so I needed some metadata. At this point, I didn't know what that metadata was. It's kind of a hand-wavy data set. We're not really sure what it is, but I needed some extra information to help me decide, does this plant need to be watered based on the readings that we currently have? Throw that into Kafka as well, mix those two data sets together, and then spit out an alert at some point, right? It's pretty simple, right? But at this point, I have mentioned Kafka more than a couple times. I want to make sure that we are all on the same page as far as what that technology is. Really basic description, it's a distributed event streaming platform. Okay, that is very concise, only a couple of words, but it's really dense. So we're going to unpack that just a little bit. So first things first, it is a distributed event streaming platform. What's that mean? So you may have noticed over the last couple of years, especially, that we've been undergoing a paradigm shift in how we actually process data. So we're moving from slower, sort of batch-focused data processing to faster real-time processing, stream processing. So instead of waiting minutes, hours, days to aggregate data in a batch and process over that batch, we are instead reacting to smaller incremental pieces of data and producing incremental results, right? So this can happen more quickly in real time. And moving to stream processing is going to increase the accuracy of your data, your results. You're going to have a more reactive system overall. And depending on how you actually go about building that and implementing your streaming system, you can have a more resilient system as well. And Kafka is a technology, is a platform that achieves this for you, okay? It can serve as that streaming, that messaging system to move information in real time. Beyond that, it can serve as a persistent storage layer and also, as we'll see, a processing layer. So it's a streaming system, but it's a distributed event streaming system. And events are really, really, really critical to Kafka as a whole. If you're going to be successful in using Kafka, you need to start thinking in events, all right? And I'm going to preface this before we dive in with, as humans, as programmers, as users, I promise, you already think in and process in events, all right? I don't want to scare you, but they're all around you, all right? We submit web forms to update information online. We are looking at application logs when you debug applications, or at least I hope you look at logs. We react to notifications on our phones and our computers. These are all events, okay? So all I'm asking you to do is just be a little more cognizant of that fact. And so those are examples of events, right? But what are they actually? So an event is a piece of information, ideally the smallest amount of information without too much excess, that fully describes something that has happened. Okay? And what do you need to describe something has happened? You need a timestamp, right? Some idea of when that thing happened. The subject, who or what was involved in that thing that happened, and any supporting details that are involved. So bringing this back to my plant system. So an event would be, say yesterday at 2:30 p.m. Pacific Standard Time, my plant had a moisture level reading of 19%. Okay, so we have that timestamp, 2:30 p.m. yesterday, PST, great. We have the subject, the who or what, and in this case, it's that umbrella plant right there. And the supporting detail that we had that moisture level reading of 19%, okay? So that's pretty simple, good, we're all on the same page here, events. But another thing to keep in mind when you start dealing with events is that they're meant to be immutable, okay? It's just an unfortunate fact of life. This is because they describe things that have already happened. As much as I'd love to have a time machine and go back and change things, I can't. It's a fact. It's something that has already occurred. I can't go back and alter that. So going back to my plant, if I want to water my plant and raise its moisture level to 70%, then does that negate the fact that yesterday at 2:30 p.m. it had a moisture reading of 19%? No, absolutely not. It simply adds a new event to that stream of events, that sort of timeline that describes the moisture state of that plant, right? We've just added another fact. So based on what you've seen so far, that Kafka can help you move information, stream it in real time, and that it communicates that facts, immutable facts are occurring throughout your system. I hope you can kind of see and start to piece together how that could be a good thing for your system. And we're going to get more into this a little bit more, but I think that's pretty wild when I first started learning about Kafka, that you can communicate these facts and then process them very, very quickly. I think that's pretty great. But how does it do that? Looking a little bit into the architecture, because Kafka is a distributed event streaming platform. So primary unit of storage in Kafka is a topic. Topics typically represent a specific or a single data entity consisting of events. And we produce events into Kafka as key value pairs using separate clients called producers. And these producers, you can write them in whatever language you want, whatever you're comfortable with. And you can have as many producers as you want, writing to as many Kafka topics as you want at a given time. From there, once data is in Kafka, you consume it from Kafka using another separate client called a consumer. Again, you can write this in whatever language you would like to. Consumers are pretty cool in that we can group consumers together, running in completely separate places, and they can all consume from the same topic or set of topics and share the work of processing and consuming from that topic. So you can parallelize the processing of your data. But consumers are also free to independently read the same set of events from a topic at the same time, all right? So that is a very, very critical thing in Kafka. So as you start to play around with this technology, the easiest thing to do is think about something similar, right? And for me, the closest thing to Kafka is a messaging queue, all right? But Kafka is not a messaging queue, all right? When data is consumed from a Kafka topic, it does not disappear. It is available for as many people to come along and read it. You should be comparing it in your mind to an application log. When you're reading through a log file and trying to debug something, you're going line by line through the facts of that application that accurately describe the whole state, that history of that application up until this point. And if you get halfway through that file and you decide, I can't figure it out, can't debug, someone else needs to come along and help me, they are free to read that same log file line by line and get the exact same information, build up that same state in their mind, and understand the history of that application as well, all right? Same thing in a Kafka topic. Consumers are free to read the same information as many times as they would like. It doesn't disappear. And furthermore, consumers are completely decoupled from producers. All right, once the producers write the data into Kafka, they don't care who reads it, and the consumers do not care who put the data into Kafka. All right, they are just consuming information from Kafka, from the topics. These topics are further broken down into smaller components called partitions. So you see on the right there, we have a Kafka topic broken down into 3 partitions. So the partitions themselves are the immutable append-only logs where the individual events are stored. So as we write an event into Kafka, write a key value pair into Kafka, it's going to be, we're going to hash that key, determine where that partition, what partition that event should live in, and we're going to add it onto there, right? And these partitions are really important, okay, because Kafka is a distributed system, because the partitions are actually stored across the nodes in the Kafka cluster, all right? And having them stored on different nodes opens up better resiliency and also opens up the doors for replication later on. So nodes in a Kafka cluster, they are called brokers. These could be running on bare metal, VMs, containers, wherever you want these to be running. So in a simple cluster where we have 3 brokers with 3 topics and 3 partitions, 3 sounded pretty great when I made this diagram. So we might be distributing the partitions of the topics like this across the cluster. So in this case, even if one of the brokers were to go down, we at least haven't lost all of the data, right? We've only lost 1 partition for each topic, which, okay, minor win, that seems pretty good, but we can do better. So if we just focus on one of these topics with its 3 partitions, like I said, being able to split things up into partitions means that we can replicate the data pretty easily now. So for each, so we're going to use replication here, and this is a configurable parameter that defines how many copies are stored across the entire Kafka cluster for a given partition. Okay? So in this case, we have a replication factor of 3. That's a pretty standard number that you'd want to use. And this means that we have our lead partitions. So we've got 0 on broker 1, 1 on broker 2, and 2 on broker 3. And these lead partitions are what we are interacting with as we produce data into and our consumers are consuming from them. But we also have a backup copy of each of those partitions stored twice somewhere else throughout the cluster. So if one of these brokers were to go down in this case, we haven't lost any data. All we have to do is look at one of the follower partitions, promote it to leader, and our producers and consumers can move on with their lives as though nothing has happened. So I think that's pretty cool. So we've all got a pretty good primer of Kafka. I hope if you have more questions about it, I'm happy to talk about it more. But let's get back to the project while you're here. OK, back to this diagram. Again, high-level look at what I wanted to achieve. But before we dive into the actual implementation details, I have another thing to admit. It's that I'm lazy. I don't really like to manage my own infrastructure. And I figured in a project where I was going to be spending so much time building the physical components, I really didn't want to do any infrastructure work. So yeah, keep that in mind as we go through this. Lazy person. OK, so I'm going to use Confluent Kafka. So Confluent offers Kafka fully managed in the cloud. So you can spin up a cluster in a couple of minutes and start writing producers and consumers, start interacting with your data. I think it's pretty perfect for projects like these, among other use cases where you don't want to touch infrastructure, but especially this where I just didn't really want to waste time on running my own Kafka cluster. Okay, I just wanted to put my data somewhere and start using it, right? On top of offering Kafka in the cloud, Confluent offers some pretty cool extra bits on top of it, some tools to help you integrate external data sources and syncs, stream processing, also completely within the cloud, and also some schema management so that you can have a contract between you and downstream data processes. So we're going to be using that. And with all of that in mind, now we can start to flesh out the details of the project. So I would start with that hand-wavy data set. I sat down and thought about what extra information do I actually need to help me compute if something needs to be watered, right? So for example, I probably need to know what moisture threshold a plant is happy within, right? For most houseplants, this is somewhere between 20 and like 60% moisture level. Give or take, if you're going to recreate this at home, test it, because I don't want you to drown a plant. So I had to do a little bit of research to figure that out. And I also figured I would want some extra information just so that if I'm poking into this data later on, I know what I'm looking at. So I wanted to know the scientific name of the plant, the given name, of course, that I gave it, and some extra things in there just to make it easier to read it later. So I'd take that metadata, throw it into Kafka, produce it in there. Next step was to actually set up that system, and I would use the soil moisture sensors to capture both the moisture and I think it gave me temperature readings for free, so I would do that. And so I would just use a Python script to pull the information from those sensors and produce it again into Kafka. And from there, with all the information in Kafka, then I can start doing some stream processing, right? It's in there. We have small pieces of information, immutable facts. We should join this information, do a little computing, and I would be using ksqlDB from this step. We'll get a little bit more into that later. But within this stage, I can determine if the readings were outside of that moisture threshold that that plant was comfortable within. And then the next step is push it to my phone. Right? Again, lazy. I want to do the easy thing. So I already had Telegram on my phone, so let's just push a message to that and let me know when I need to water my plant. All right, let's build something. I know this isn't a hardware conference, but I love talking about this. OK, so if you want to do this, these are the components that I had. This Raspberry Pi, absolutely overkill. OK, I totally could have done this with a Pi Zero, but you can't get one now. They're really expensive. So yeah, this was overkill. This is the only Raspberry Pi that I can get my hands on. So I ended up using that. I used a half-size breadboard. I didn't know that I needed a breadboard because, again, first project. But this came for free with my order. It's like they knew. They're like, this girl's an idiot, so we're going to send her one. So I ended up using a breadboard. And I did a lot of research on moisture sensors. There are a lot of them out there, OK? A ton of options for Raspberry Pi. I settled on these Stemma I2C capacitive moisture sensors. I think they were pretty high quality for the cost. They were pretty cheap. And as a capacitive moisture sensor, they were going to last a little bit longer than others available. So settled on those. And beyond that, I decided to cut and crimp all my own wires. Just super fun. Yeah, that was really great. So purchased some JSD connectors and ended up using a couple meters of wire in the end. And the last component of my physical setup were the willing participants. So I chose these plants in a really scientific way. They were all on the same table, and behind that table was an outlet. It was perfect. I had to do it. So with the hardware and the plants decided on, I could actually go ahead and build the system. Insert hand waving here because it's not a hardware conference, but talk to me later if you're curious. Yeah, so suffice it to say, after a lot of soldering and crimping and maybe a couple tears, I ended up with something like this. Don't judge it too much for those of you who do hardware. Yeah, so these are a couple of the sensors hooked up to the breadboard, in turn hooked up to the Raspberry Pi. I know I said in the beginning that I have 4 dozen plants, and there are quite a few plants on that table in the previous slide. I was only able to use 4 sensors in the end, and this was a hardware limitation on the sensors that I purchased. So they are I2C sensors, meaning that in order to get information off of them, you have to know their I2C address, right? They're all hooked up to the same wires, the input channels into the Raspberry Pi, and in order to identify a sensor, I need to say, okay, give me the reading from that unique address. Unfortunately, these sensors only have 2 bits on the back that you can solder, so we can only do 4 unique addresses across these sensors. So for now, iteration 1, there are ways to get around it outside of the scope of this project, but I can only hook up 4 sensors, unfortunately. So these are all wired into the breadboard, and then they're wired into the same input channels that then go into the Raspberry Pi. Moving on so you don't judge my soldering. And the software. Again, if you're curious to poke into this, Python 3.7, and I also installed the Confluent Kafka Python library in order to set up some producers to write the information to Kafka. On the Kafka side of things, as I said, didn't want to set up infrastructure, so I'm just driving this home. I set up my cluster in Confluent Cloud, took a couple of minutes, and I'm also going to be leveraging stream processing in the cloud using ksqlDB, as well as some managed connectors. Again, all of this is fully through the cloud, didn't have to leave the web UI to actually do the Kafka portion of this. So, if you take one thing out of this, okay, it's that it's this component, okay, schemas and understanding the data that you're using. So whenever anyone asks me where should you start with any sort of data-related project, I say, okay, take a step back and actually understand the data set you're working with. I feel like too often you kind of just do a little hand waving, you glaze over it, you just dive right in, and then you're like, well, wait, I thought the data would look different, and then you're stuck cleaning things up, and it's not really fun. So, especially in situations like this where you're creating the data, you have absolutely no excuse, okay? I know it's easy to be lax and say, oh, I don't need a schema, I'm the only person looking at it. Wrong, okay? I've got an intern now and he's using this data, all right? So good thing I set up a schema. So the great thing about schemas, I know they take a little bit of time to set up and think about, but that's the benefit of it. You take a step back and you think about the data that you're going to be working with. What fields do you actually need? What type should it be? Okay, and I went through a couple iterations in this process just to make sure that I had the data sets that I wanted to be creating and that I wanted to be working with later on. So I set up 2 Avro schemas here, one for the actual houseplants data, so that's on the left here, that metadata, right? So I had, in addition to the scientific name and common name of that plant, I also had the moisture levels that they're comfortable within, that lower threshold and high threshold, and the same thing for the temperature as well. And on the right, I created that schema for the actual readings that were going to be pulled from the sensors. So it grabs the moisture, grabs the temperature, and of course has an explicit timestamp that I store in there as well. And both of these schemas also have a plant identification number that is going to serve as, help me keep track of each plant and then serve as the key that I can then use to join these data sets together later on. So schemas, know your schemas. All right, so with the schemas defined, now I can actually start getting my data into Kafka. How do we do that? There are 2 main ways to do this, the Producer API and Kafka Connect. I know I have verses up there. I'm a really confrontational person, so I just like to cause trouble, but it's really not a competition, all right? There's going to be specific cases where you want to use the Producer API over Kafka Connect and vice versa. So the Producer API, as I mentioned earlier, this is your low-level sort of vanilla option for getting data into Kafka, available in all of your favorite languages and some of your least favorite as well. So you'll want to be using the Producer API when you either own the application that's generating the data or you have access to it, right? So if I wanted to, for example, send some like log events into Kafka and I own the application that's generating that, okay, add a line, add a producer. When you capture that event within the application and you're logging it, also push it into Kafka at the same time, produce it into Kafka, all right? The other option is Kafka Connect. And this is, I love Kafka Connect because it's way too easy to use, all right? So it's a low to no code option, completely configuration based. And as the name implies, it's your way to connect Kafka with other data sources and syncs, okay? So there are hundreds of connectors available already pre-written to help you connect to that many data sources and syncs. And so yeah, you just define a configuration file, or if you're doing it through Confluent Cloud, where there are dozens of fully managed ones, meaning that you just walk through basically a configuration wizard to connect to your data sources. Yeah, it's just completely configuration based. It's pretty easy. And so this is a really great option for data that you don't own. You know where it is. Maybe it's at the, in a database somewhere. Maybe it's in some files or at the other end of an API call. Really great for, reference data or lookup tables, things that extra auxiliary or reference data that you need to have in Kafka for later on. Okay. So what did I end up using in my case? Probably both, right? Wrong. I ended up using the producer API and only that. And this goes back to the fact that for my metadata probably exists in a database somewhere, or it should be, right? I only had 4 plants worth of data for my metadata, right? So being lazy, didn't want to set up a database, didn't think it was necessary, so I used the producer API to serialize or build up those objects, that metadata object, serialize it according to that schema that I wrote, and use the producer API to just push it into Kafka. I did a very similar thing for the readings. So to start it off, though, I created a static mapping of the plant IDs to the I2C address, and then just looped every 5 seconds in the Python script, grabbed the readings at that address, and produced it into Kafka. All right. Everything's in Kafka now. Now we can get moving. Once data is in Kafka, then we can start actually doing the processing. Right? And there are a couple different ways to go about it. They all have their trade-offs, so it's up to you to decide what you want to play around with. The OG way to produce data or process data from Kafka is with the consumer producer API. All right? So again, this is your low-level option, flexibility because it's available in all your favorite languages. But to use it for stream processing, depending on what your use case is, you're going to have to set up a consumer to consume data from Kafka, right? Do your transformations in memory. If you have any sort of stateful transformations you want to be doing or aggregations, all right, got to manage that yourself. How are you going to handle failover? I don't know. Figure it out. And then once you're done with that, once you've done your transformations, your aggregations, you produce it back into Kafka with the producer. Okay. Obviously, that involves a lot of work, but you have a little bit more flexibility in what you can do at that level. So, I don't know, to each his own. That said, if you're sane, you're going to use one of the next 2 options for stream processing, for data processing. Next up is Kafka Streams. So this is a Java and Scala library specifically written for stream processing. Okay, so it excels at stateful operations. You get a lot of these cool transformations off to the right. You can see filtering, mapping, joining, windowing, aggregating. And the really cool thing is that it takes that hassle of managing state off of your hands. Okay, it has built-in mechanisms to handle stateful transformations and the failover that might be involved in that. Okay, and because it's built on top of the consumer and producer API, and because consumers can share the work and parallelize processing, you get that for free in your Kafka Streams applications. So you can spin up multiple applications, multiple instances of it, and they can all share the work of reading from the same input topics and parallelize that processing. Okay, and in the event that one of those instances goes down, it will rebalance, move that state over to the active instances, and you just keep going, right? So that's all taken care of for you, which is pretty great. So see, consumer producer API doesn't look that good now. And the next option, if you just want to make it even easier, ksqlDB. So what if you could spin up a streaming application using SQL? You can. So the great thing about ksqlDB is that you don't have to write any code to make it happen, and it spins up a streaming application under the hood, a Kafka Streams application. So effectively, you write some SQL, define what information you want to get, what aggregations you want to happen, and it will build a streaming application for you underneath. So you have that, you're completely removed from that process. You don't have to think about it. And so you can easily filter, join, do your windowing if you want, all with pretty simple SQL syntax. And then the final benefit of that is that you can do this completely within the cloud, just in a SQL editor. So this is what I ended up using, just for simplicity. So processing with ksqlDB. So to build a streaming application with ksqlDB, you first need to be aware of the two first-class objects in it, tables and streams. Streams represent unbounded, ongoing series of events. Tables, on the other hand, represent the most up-to-date value for a given key. Right? I'm going to end up using both of these for my two data sets. So let's see how to create a couple. So the first thing you should note is that the syntax is going to feel very familiar. It is effectively SQL. The first thing I did was build a table for my houseplant metadata. All right? So the houseplant metadata exists in a Kafka topic already in my Kafka cluster, but to make use of it in my ksqlDB application, I need to basically register it as input data, as an input data set. And to do that, we're just going to put it in a table and make it available to use. So I chose to use a table here for a couple of reasons. Again, metadata is probably something that exists in a database table to begin with. And if I'm ever updating anything, I just want the most recent value of that, right? If I'm updating the metadata saying, no, it's actually comfortable with 25% moisture, right? I want to get that information and have that most recent value reflected immediately in my streaming application. So made sense to do that in a table. A couple things to note here. So the top's going to feel pretty familiar, again, that sort of SQL syntax. But what we have at the bottom is basically you create this table and you point to the Kafka topic that is backing that table. Where are we getting this information? So it's just going to point to that houseplant metadata topic. And then we specify the Avro format, because remember we wrote those Avro schemas to define this data. And because of that, because we took time to write that Avro schema, a really cool thing happens. All right, so since we wrote that schema along with our data into our Kafka cluster, that schema is now stored in the schema registry along with our cluster. So ksqlDB, our application, as a consumer, can go access that schema within the schema registry and use it to automatically parse the fields and the types from this topic. So there were, 8 or 10 fields in that topic, in that schema, and I only had to define one here. Right? The only thing I had to specify was what field are we using as the primary key, because again, we need a key for a table to update the values per key. Okay? Every other field is brought in automatically as part of this. All right? We don't have to specify it, don't have to mistype something. Really good. And once I write this query, then I can go back to the ksqlDB editor within my browser and execute this. And it's going to create that table, make it available, and we can start querying it if we want behind the scenes. So for the readings data, probably going to put this in a stream, right? Because every message on that topic is valuable. It describes the state of that plant, the moisture state of that plant, right? So every message is relevant, every message is valuable. We should put it in a stream. Again, I'm using Avro, so this is even easier. The ksqlDB application can access that schema under the hood from the registry and then use that to parse every single field. I don't have to specify a primary key. That's not important in a stream. It is just I just have to point to that Kafka topic, specify the value format, and it will create this stream along with all the types in its field parsed. I've got my table in Kafka in my ksqlDB application. I have my stream in the application as well. The next step is to actually combine them, right? Because the readings aren't very useful without that extra bit of knowledge from the metadata table, right? So we're going to do a stream to table join to actually combine these two things. So we're just going to focus on the select statement first. And this is going to seem, again, it's just a regular SQL select statement, right? Select these fields from the reading stream, and we're going to do an inner join on the metadata table. Okay, we're joining on the ID field, and we're doing an inner join just to make sure we have all the information we need for the next stage, right? I want to have both data sets to move on. That seems pretty simple, right? Where this gets just any bit different from SQL is the top right here. We are creating a stream from this information. So this select statement, this is wonderful. If I just ran this select statement on its own, it will give me all the information that's currently in that application. It'll do that join and spit it out. Done. But the readings topic, the reading stream, is constantly having updates put on it, right? So I want to have those constantly be reflected in the output of this query, right? So first thing, I'm going to persist the output of this statement to a stream. I want to save it there so I can use it in the next step. So to do that, we're creating this stream, the enriched stream, telling it which Kafka topic to store this stream in, telling it the value format, and then the important keyword here is emit changes at the bottom. Okay. By adding emit changes to the end of a ksqlDB statement, we are requesting a push query, meaning that every time a new value comes in on the stream, that's part of this join, we're going to execute this join, do whatever is indicated in the select statement, and we are going to output that and persist it to the stream, right? We're going to emit all of the new changes that come through on that topic, on that stream, okay? And it's going to be pushed to me as output. And this is contrasted with a pull query, which is where I'm just pulling a finite result set that reflects the current state of the underlying streaming application, right? So here, I just want a one-off response. Show me the current state of this metadata table. Specifically, give me the names of the plants whose low moisture threshold is, that is not what it's supposed to be. That's fun. That's really weird. Anyway, it's supposed to be reflecting the low moisture threshold above 20. So we're going to pretend that that's there. That's weird. Cool. Love that. Cool. Let's act on the data now. All right. So I have an enriched stream that has the readings joined to the metadata. So now we have all the information we need in a single message, in a single row in ksqlDB. So let's make sense of this data, right? So revisiting the overall goal here. Whenever a plant has enough low moisture readings indicating that it needs to be watered, right, I want to send an alert. I want to receive an alert on my phone. But how do I determine when to send that alert? And then also, how often should I send that? This is pretty easy because I'm the only stakeholder, but it's an important thing to reason about. So I thought about this a while, right? So I'm taking these readings every 5 seconds, correct? And if I have a low moisture reading every 5 seconds, that's going to inundate my phone. I can't do that. Absolutely not. So I figured if I'm out of the house or just busy, it's probably good enough to receive an alert at most once every hour, right? So, all right, so we're going to work on an hourly basis. But I also noticed that my sensors weren't perfect. And I feel like I've heard this is a very common thing with any sort of hardware project. So after running them for a bit, I kind of noticed that I can really, really easily get low, false low or false high readings. But the general trend over time is that the moisture level would decrease, right? So after looking at the data a little bit, I decided that within a 1 hour period, it would probably be good enough if I received 20 minutes worth of low readings, that probably says that plant needs to be watered, right? That's probably good enough to indicate that we have breached that threshold and we should water that plant, okay? So running that math, it's taking readings every 5 seconds, 240 low readings within an hour, so 20 minutes worth of low readings is 240 low readings within an hour, all right? So we should wait until we get to 240 to trigger an alert. And this is the query that I wrote to actually make this happen. All right, first thing we're going to focus on is I said I wanted to receive at most 1 alert every hour, okay? We're going to do this by setting up a non-overlapping 1 hour tumbling window. okay? Which I think it's wild that you can just do this with one line, just a couple words. And so the first thing we're doing is breaking up all of the input data into 1 hour blocks, effectively. And then from there, we have this filter in there, okay? So if the moisture from the reading was lower than the low moisture threshold, we are going to count that, okay? And if I have 240 low readings within that 1 hour period, we are going to actually output a row from this query. And I want to just go back and explain this a little bit more because it might seem a little wonky, and I just want to make sure we all understand what's going on here. So whenever we are windowing and conducting some sort of aggregate, the output is a table. And that might seem a little weird, but it makes sense when you think about it more because a table has a row where it's computed per key per window, okay? And whenever we're showing the current state per a key, it should be a table, all right? So the query is operating over all of the input data, right? Every time we do a join, we have a new reading. It's going to be joined on that, the metadata, and it's going to be an input parameter for this query, right? As every record is processed, if it meets this, this filter requirement, if the moisture is lower than that low moisture threshold, it's going to increment the state. So this is a stateful operation that's occurring per window per key, okay? So there is a 1 hour state associated with each plant, okay? So if that event happens to meet that filtering requirement, it's going to increment that state, okay? We're going to start at 0, increment at 1, 2, 3, 4, so on and so forth through 239. Nothing happens at that point. We are just incrementing the state up until that point. We're not outputting anything. As soon as we get that 240th reading, that is when a row is output as a result of this query, okay? And the result of this is that I'm only going to receive at most 1 alert per plant ID, right? Per window, which is exactly what I wanted. So now I have a Kafka topic. I persisted that to a table. I have it persisted to a Kafka topic. All I need to do is get the information out of Kafka. And for this, we're going to be using Kafka Connect. It is your way to connect external data sources and syncs with Kafka topics, okay? I said before that I wanted to receive this alert on my phone, and I already had a Telegram app. Cool thing about Telegram, if you have it, you can actually set up a bot. I'm pretty sure this is not the use case they had in mind. You can also play around with some like AI stuff and just build a full bot, which is pretty cool. But I was able to set up a bot, get a unique API key to actually access that bot. And then they also have a chat API so that you can use your API key, send information to an endpoint, and once you've started a conversation with that bot, you can send information to your phone from it, which is pretty cool. So doing that, I set up my bot, got that information, and I then had a convenient endpoint that I can just send data to. And conveniently, there is a Kafka sync connector for HTTP. Okay, you have an endpoint, you can just send whatever data you want to it. All right? So to get this sync connector up and running, so this is a JSON that's kind of like spat out at the end once you've defined your connector, but it was a walkthrough sort of wizard to set this up. So a couple things to take note of. We point to the topic that we're actually pulling information from that we want to get out of Kafka, which is our low readings topic. We specify that endpoint, so this has that API key. We're just using the send message endpoint. And from here, I'm just sending a string to it. I have to specify the chat ID that I've set up, that conversation that I'm having with the bot. And then I'm using regex to grab the message field from that topic that I just created and just package it up to send to that endpoint, right? And so once this has happened and I run my connector, it takes a couple minutes to set this up, but then this is the sort of alert that I receive on my phone telling me that my plant's complaining and it needs to be watered, right? So, which I'm pretty happy about. I've gotten a couple of these now. I need to get home to water my plants. But anyway, so that was fun. I think it was pretty fun. I built a useful thing that I can use, and it solves a very real problem in my life, right? But I know you were here for the fun of it. but I tricked you, okay? This is actually going to be useful for you as well. If you're looking to utilize Kafka to get into streaming data, to build a streaming data pipeline, I just gave you all the tools you needed to actually make that happen pretty easily. So if you wanted to turn around, leave, and build a POC, you can do it in 15 minutes if you really wanted to, all right? So when you're building a streaming data pipeline, you're going to have some combination of these three stages, right? You're going to have your ingestion stage, where you're setting up a producer from an application that you already have, or you're spinning up connectors to pull data from some data sources or APIs, and you're pushing into Kafka. From there, you can pretty easily set up a streaming application, whether you're doing that with consumers and producers, or Kafka Streams, or ksqlDB. You then can work to combine those data sets, transform them, filter, massage the data, whatever you want, doing that within the context of Kafka. And then wherever else you want to move it later on, either for further downstream analytics or just to store it long term, there are a host of other connectors that you can use to do that, or you can set up a consumer to do that as well, to move it to downstream. So yeah, every streaming data pipeline is going to involve some of these steps, and I just showed you exactly how to do that. So keep that in mind the next time you want to get started with one of these. And if you are looking to get started in a couple, right afterwards, I hope so. A couple resources to kick that off for you. On the left here, we have our Confluent developer resources. We have a ton of free courses there that walk you through pretty good demos on like Kafka 101, what is it, how do you play around with it, ksql, Kafka Streams, Kafka Connect, all of them. Data mesh, if you're feeling wild. We've got a data mesh demo. So all those are available for you to check out. And then on the right, if you're interested in digging into the source code in the configurations and scripts for my project, I welcome you to do so. And that is all that I had for you today, so I'll open it up now for some questions. Yeah.
We've been looking at the Confluent thing. Is there when you actually go to actually set up the stuff, is there a free tier or a cheap tier for actually testing these things out with, or what's the cost of actually newing up, real Hello World app under Confluent?
Yeah, so when you start up with those and you create a new account, you automatically get, I don't know, it's a couple months of free usage to begin with. And then on top of that, for each course that you take, we give you another promo code that you can get like $100 of free usage on top of that. So I think if you're just walking through all of those, the sort of Hello World stuff, or if you want to just build a POC, you have more than enough free usage thrown around to make it work. Yeah. Yeah.
Have you tried using it on Houseplants?
Have I what?
Tried using it on Houseplants?
I did not. That's something I want to do. I'm in the process of moving, and I'm like, cool, what can I set up that's permanent in the house, right? But no, the sensors that I have, they are not rated for outdoor use. I even get worried watering them because I don't believe that the top of it's coated with the actual components. So I'm very, very wary of that. But that was one of the things that came up that I'm working with a local nonprofit farm to see if we can set up more IoT stuff throughout there. They have it's a really small farm. They have a couple acres though, to see if I can build something a little more robust that can hang out on their property. So watch out for the next iteration. Yeah.
Did you consider using AS332s?
I did consider that. That came up a couple times. They're certainly cheaper. It was really just a selfish thing. I wanted a Raspberry Pi, and this was something I could expense. So I got the Raspberry Pi, and I'm also building out a couple. I just love the plug-and-play components. It's just, and all the tutorials that are available. I think I got it all in Adafruit. Yeah, so I have like a whole slew of projects that I'm going to be building with the Raspberry Pi moving forward. But yeah, that keeps coming up. So we'll see. We'll see if another, I think if you ask my colleague Chris Jenkins, he'll be speaking at the end of the week. I think he has some stuff in mind for that trip.
It's a small one.
Yeah.
The plant is a poorly leaf. Is that okay now?
Yeah, no, it's fine. They're just so dramatic. I don't know why they are that way. It's like, sometimes I see it and it's wilted. I'm like, just shut up. It's like, you're being so dramatic. The rest of the plants aren't like that. I don't think I've ever seen a plant as wilty as that. Like, you just look at them wrong and they wilt. But thank you for asking.
I have a question about the ksqlDB.
Yeah.
I know that Kafka consumers are typically done on the client side or the application side. Is ksqlDB
Yeah, it's hosted wherever. So when you set up your cluster, you choose what cloud provider you want to use. So yeah, it's run outside of the cluster, the Kafka cluster, sort of alongside it. But yeah, when you set up a ksqlDB application, it kind of sets up its own little cluster depending on how many instances you want and what, what sort of processing power you want behind it as well. But yeah, it is a separate thing, but still hosted on whatever cloud provider you want. Cool. Anybody else? And I will be here all week, so I'm happy to chat really nerdy plant things. Usually, for every talk I give on this, I steal a plant. Oh, I borrow a plant from somewhere in the conference center. There were some fake ones out there. I was really disappointed. But yeah, I usually try to make it a little bit more fun. But happy to talk about plants, Raspberry Pi, hardware, next things I should do, because I'm getting a little bored and I'm thinking about what the next thing I should build should be. And yeah, of course, Kafka. Happy to chat about Kafka. Yeah?
I'd like to ask a question. I'm adding this because I was kind of watching it live in transit and then transitioned into the room. But did you look at using MQTT, which a lot of the IoT type devices use? And then how would you, because obviously you've got the SQL part, the analysis part, have you ever looked at how you use the two together?
Yeah, so MQTT, that did come up. I wanted to just use all, I wanted to be able to showcase the producer API as well. So settled on that and already had a pretty quick script already written to do that. But if you did want to go that route, there is a connector to pull information from MQTT and move it into Kafka. So the thing about doing any sort of processing with Kafka streams or ksqlDB, your information needs to be in Kafka for you to do that. As soon as you start, if you're using like a Kafka streams application, as soon as you start making external data calls, you just ruin it. Right? You want all the data to be in Kafka already to quickly do joins, to quickly aggregate. So in that case, even if you had the information in MQTT, you would just want to use a connector to pull that into Kafka first and then do it. But yeah, if you did go that route, there's a solution. Cool. All right, anyone else? I feel like every time I say anyone else, it's like, no, but then another. Cool. All right, thank you so much. I really appreciate it, and I'll catch you all at the rest of the conference. Thanks.